We reach question number 5 from the document. The document has more than around 84 questions, so we cannot solve all of them. I'm going through the challenging question, or the question that I see that you will have difficulty in solving them. The rest of the questions, you already have the solution. I shared the solution with you on Google Classroom. Now we reach question number 5. 5, we have a ball thrown vertically upward. Air resistance is negligible. What is the variation with time of the kinetic energy of the ball? Now you have ball thrown upward. So I will start with maximum velocity. The velocity initial will be maximum. That means the kinetic energy as well will be maximum. Then what will happen to the velocity? The velocity will start to decrease till it reach 0. The final here at the maximum height will reach 0. And then the ball will change its direction. The velocity will start increasing till it reach maximum again. So maximum kinetic energy, then it reach 0, and then change its direction, will have maximum energy again. So the correct answer is D. Question number 6. You have the tension in a horizontal spring directly proportional with the extension of the spring. The energy stored in the spring at extension X is E. So you have a spring. If I apply the force in this direction, the spring will be extend distance X. Okay. Now the energy here is E. So this one I'm going to call it E1. What is the work done by the spring when the extension changed from X to become X over 4? X over 4 means I will have a compression in this direction. So here, the compression, it will be X over 4. And I need, here will have different energy. I needed work. I know work, this change in kinetic energy is the same as a change in the potential energy. Now, the type of energy here is elastic potential energy. So I have to find the change in the elastic potential energy. Change, it means final minus initial. Now, how can I find the elastic potential energy stored in a spring? E, the energy is half the spring constant times the displacement squared. Now, this is E1. E2 will be half spring constant displacement is X over 4 squared. So this will be X 4 squared 16. So I will have 1 over 16, 1 over 16 half K times X squared. So energy 2 is equal to 1 over 16 of energy 1. This is the same as the energy at position 1 when the extension is X. So if I find the difference between them, 1 over 16 E1 minus half E1 will give me 15, just ignore the negative, 15 over 16 E. So the correct answer is E. Number 7, we already solved it in the question. We already solved this question in separated video. You will find the solution in the attached playlist, the link of the playlist of paper 1. You'll find it there, the solution of question number 7. Now we'll go to question number 11. You have a stone is thrown downward from the edge of a cliff. So here you have a cliff and a stone is thrown downward with initial speed. So u initial here is 5, and since it's downward, this will become -5 meters per second as it hits the ground. After time, 2 seconds later, I need the height of the cliff, So this one, delta y, or s and y direction, how much? Okay. So I can use this formula, s and y direction or delta y. S in y direction or delta y will equal u initial in y direction times time plus half acceleration y direction times time squared. U initial is -5, time is 2. Acceleration in y direction, we'll take it -10 meters per second squared. So -10 divided by 2 to become -5 times 2 squared, and this will give us -30 meters. So the answer is B. Okay. Now, projectile motion, you have a ball is thrown upward at an angle to the horizontal and resistance is negligible. Which statement is true about the motion? When you have a projectile motion, this is the initial speed. It will go to the maximum height. The initial speed always I have 2 components. One in x direction, and this component is constant, doesn't change. And the other one here in y direction. The component of x direction always constant. So I'm going to draw the same length of the velocity in x direction. The velocity in y direction, when you throw it up, we start with maximum speed, and then this speed will start to decrease till it reaches 0 here at the maximum height. So at the maximum height, this one delta y maximum, the velocity 0. Time here at the maximum height, time, we call it time at the peak, will equal the total time when it's land divided by 2. So here it will land and reach here the ground. Now, once it reaches before it reaches the ground, the speed, velocity in x direction almost constant, velocity in y direction start to increase till it becomes maximum just before it hits the ground. Now, once it hits the ground, delta y here will equal 0, and t time total here will be double the time at the peak. So the velocity of the ball is 0 at the maximum height. The velocity of the ball is 0 at the maximum height. Okay. Now this question 13 is easy. mg times the height h. Question 14, you have 2 blocks. The first block, it has mass 2m. Second block, it has a mass m. They move against each other. Once they collide, they stick together. Momentum always is conserved, whether they stick together or they move separately. So what is the P initial? P initial is the first object times the velocity initial of the first object plus the mass of the second object times V initial of the second object. To the right is positive, velocity to the right is positive, velocity to the left is negative. So mass of the first object is 2m times the velocity v. Mass of the second object is m, velocity is negative, so it will be minus m times v. So this is P initial. 2 minus 1, it will give me m times v. Now momentum is conserved, so P initial should equal P final. Momentum before is mass times velocity, and momentum after I don't need to calculate it because it should be the same but in the opposite direction. Okay. Sorry, it should be the same. So the correct answer should be F. Should be the same. It will move to the right to the direction of the biggest object, which is 2m to the right. Now, question 15. You have a graph that shows the variation with time of the resultant net force acting on the object. The object has a mass 1 kilogram and it's initially at rest. What is the velocity of the object at 200 milliseconds? Now you have here velocity versus time graph. Now from Newton's second law, force equals change in momentum divided by change in time. Change in momentum, the thing that's being changed here is the velocity, is mass times change in velocity divided by change in time. If I do cross multiplication, force times time will equal mass times velocity. I need the velocity because the question, they want me to find the velocity. So the velocity will equal force times time divided by m. Force versus time, this will give me the area underneath this graph. So delta V, I'm going to calculate the area divided by m. Now how am I going to calculate the area half? Base here is this distance is 200 milliseconds. So 200 times 10 to the power negative 3 times the height. The height here is 80. So if you calculate this one, you should get 8 meters per second. Here we'll go to question number 17. You have an object. The object has weight. So this is Fg, 6.1 times 10 to the power 2 Newton. What is the change in the gravitational potential energy of the object when it moves 8 meters vertically? Just this is the formula and apply. I know gravitational potential energy is mgh. Mg is the weight times height. Weight we have 6.1 times 10 to the power 2 times the height 8. This will give me 4,880 joule. Write this one in scientific notation. When you write it in scientific notation, you put the point to the right. And if you don't have a point, move it till you have only one digit. So we'll have 4.88. Now, when you have multiplication, always you round to, this is times 10 to the power 3 joule. You round to the least significant figure. Here I have three significant figure, 1, 2, 3. And here I have 1, 2, 2 significant figure. So when I round it, I should round it to 2 significant figure. So this will be 4. Add 1, 9, 10 to the power 3 means kilojoule. So it will be, the correct answer is 4.8 kilojoule. 4.8 kilojoule. Okay. Now, second question. Okay. Question 18. You have a boat with an outboard engine. The power 15 kilowatt. This is P. Okay, moves through water at speed. So the velocity is 10 meters per second. What is the resistive force acting on the boat? Now I know the power, energy over time, change in energy divided by change in time, which also equal force times velocity. Power is 15 kilowatt, that means 15 times 10 to the power 3 equals We don't have the velocity, but we don't have force. The velocity is 10. So divide both sides by 10. F will be 15 times 10 to the power 2, which will equal 1.5 kilo in Newton. Kilo in Newton. Okay, we'll go to question number 22. Okay. You have a sports car is accelerated from 0 to 10 kilometers per hour. So V initial 0 and V final is 10 kilometers per hour. Time is 3 seconds. I need to calculate the acceleration. Okay, now I'm going to convert this one to SI unit. So V final is 100 kilometers per hour. Since I have 2 units, I'm going to open 2 conversion factors. Okay. Now I need to convert from kilometer to meter. The unit that I need to convert to, we put it here on the top. I need to get rid of kilometer. I put it down. Kilo, it's a prefix. Next to the prefix, you put 1. 1 kilo, it means 10 to the power 3 meter. Now we get rid of kilometer. Now hour is down, so I'm going to put it up. I need to convert to second. We put second down. 1 hour is 3,600 seconds, 60 times 60. Now we've got rid of hour. So 100 times 10 to the power 3 divided by, so I have 100 times 10 to the power 3 divided by 3,600. This will give me 27.77 meters per second. Acceleration is a change in velocity divided by change in time. V final minus V initial divided by time. So V final 27.77 times minus 0 divided by 3. This will give us 9.3 meters per second. But the question here, I have G. So what I'm going to do, I'm going to multiply by G, free fall acceleration divided by G. The free fall acceleration is 10. So 9.3 G divided by 10. This will give me 0.93 G, rounded to one significant figure. So the correct answer is B. 9.9 G. The correct answer is C. 0.9 G. Okay. Now we'll go to question number 25. Okay. You have a boy. A boy throws a ball horizontally at speed 15 meters per second from the top of the cliff. So here you have a cliff. The boy throw a ball horizontally. This is horizontal in X direction. The initial speed in X direction is 15 meters per second. The cliff height is 80 meters, so the distance from here till here, delta y or S in Y direction is equal 80 meters. And is negative since the motion is down. Now, what is the distance from the bottom of the cliff to the point where the ball lands? The ball will land here, will go in a parabolic path downward. So I need this horizontal distance, delta x or S in Y direction. Delta x or S in Y direction, in X direction. Delta y is S in Y direction, same thing. Now, when you have this projectile launched horizontally, always you follow the same steps we learned in the class. You make a table. X direction and Y direction, horizontal and vertical direction. Horizontal direction, we only have one equation since we don't have acceleration in X direction, acceleration X direction 0. So the only equation we'll have is delta X equals U initial X direction times time. U initial in X direction 15, but we don't have to the time. So we need to find time first. This one we can find it from the equation in the vertical direction. In the vertical direction, we have three equations. I'm going to use so that equation that has Y because Y is given to me. So acceleration Y direction is negative 10 meter per second square. Delta Y in Y direction, the initial velocity in Y direction is 0. So initial velocity is 0, so it will be half acceleration Y direction times t squared. Negative 80 equal negative 10 divided by 2 is negative 5 t squared. Divide both sides by negative 5 and take square root for both sides. So t will be square root of 80 divided by 5, and this will give us 4 seconds. I'll substitute here. So delta x or s in x direction, the displacement in x direction will be 15 times 4. 15 times 4, it will give us 60 meter. 60 meter. Okay. Now we'll go to question number 27. 27, you have a graph that shows the variation of momentum with time for an object. What is the net force acts on the object for the first 2 seconds and for the second 2 seconds of the motion? So here you have momentum versus time, and I know from Newton's second law, force equals change in momentum divided by change in time. So force will be the slope of momentum versus time graph. So I have to find the slope, find the force. Now in the first 2 seconds, the slope here is this distance, rise over run. So this one will become 20 minus 0 divided by this distance from here till here, 2 minus 0. 10 divided by 2 will give us 10 Newton. Yeah. Now second, 2 seconds, 2 seconds. Here first 2 seconds. Now second 2 seconds. The slope here, the slope is 0 because I have a horizontal line. The value of the momentum all the time is 20. So 20 minus 20 will be 0. So the slope is 0. The force will be 0 on this side, in this particular part of the motion. So the correct answer is A. 10, the first 2 seconds, and 0, the second 2 seconds. Okay. Now question 28. Question 28 just applies to that equation. You have a truck, has initial speed 20 meters per second, deaccelerate. When it tells you deaccelerate, that means the acceleration is negative. So this value to become negative 4 meters per second square. This is the acceleration. What is the distance taken by the truck to stop? To stop, that means V final will equal 0. So I need the distance delta x. So V final or S. It's that equation. So V final will equal U initial, V final square, will equal u initial square plus 2 acceleration times the displacement. S or delta x. V final 0. U initial is 20 square plus 2. Acceleration is negative 4 times S. Take this to the other side and simplify. So I will have negative 400 will equal negative 8 times S. Divided both sides by 8. Okay. So S will be 400 divided by 8. So the answer is 50 meter. Okay. Now we'll go to question number 32. If you have any question regarding the question that we haven't solved, you may ask me. The document, I'm going to share it. You already have the document. I share it with you with the answer key. So we go to question 32 now. 32 here. You have a ball. The ball has mass m, collides with a wall, and bounce back in a straight line. The ball loses 75% of the initial energy during the collision. I need the speed of the ball before the collision is v. Okay, what is the magnitude of the impulse on the ball by the wall? Okay, now when 75% loses energy, that means the ball retains 25% of the kinetic energy after collision. So I have 25% of the kinetic energy final after the collision. The ball retains this energy. Now, how can I find the impulse? Impulse is force times delta K is the same as change in momentum. Change in momentum, it's mass times change in velocity. Change in velocity, V final minus M, since I have the same ball, U initial. Now the kinetic energy initial or before it collides, initial, is half M V squared. Kinetic energy final after it collides, we said it retains 25%. 25% retains of the initial energy. Okay, so kinetic energy final will be 25% of the kinetic energy initial. 25%, it means quarter of the kinetic energy initial retained. So this one, it will be half M V squared. This is after. This is after. This is after. Will equal 1/4 kinetic energy initial is half M V squared. This is before the collision. Half M and half M, they cancel each other out. So V squared after will be 1/4 V squared before. If I take a square root for both sides, V after will be half V before. And since the ball hit the wall and then bounce back, it will bounce back in the opposite direction. To the right, the velocity is positive. Left, the velocity is negative. Here, positive. Left, I will have negative velocity. So I'm going to put negative sign to the left. This one is negative. Now we need to calculate the impulse. Impulse will equal M times V final minus V initial, or V after minus V before. Now the same velocity, so in V I can take V outside. V after, it's minus half, minus V initial is 1. Minus half minus 1, it will give me minus 3 over 2 M times V. This is the impulse. So the impulse will be 3 over 2 M times V. Okay. Now the last question I'm going to solve, and then we'll continue in the next videos, inshallah. Question number 38. Okay, you have an object falls from rest. Initial speed is 0. From height h close to the surface of the moon. The moon has no atmosphere, so no resistance. When the object falls to height h over 2. So here initially I have h. The type of energy, initial energy at this position here, it's only gravitational potential energy. The object will fall. It will reach h over 4. So the type of energy here, final energy, is potential energy and kinetic energy, because the object is still moving. So I'm going to use the conservation of energy. Mechanical energy initial equals mechanical energy final. I start up with gravitational potential energy at the first position. At the second position too, I have kinetic energy plus gravitational potential energy. So gravitational potential energy, mgh, will equal kinetic energy plus mg at position 2, the height is h over 4. Rearrange it, keep the kinetic energy alone by itself. So take this to the other side. I will have kinetic energy equals mg h 1 minus 1 over 4. When you take this to the other side, mgh, take it outside as a common factor. So I will have 1 here minus 1 over 4 will give me 3/4. So this will be 3/4 mgh. This is the kinetic energy. Now the question is, what is the kinetic energy at height h over 2 divided by the gravitational potential energy at height h? This is the question. The kinetic energy, this one. So the kinetic energy at height h over 2 is 3 over 4 mgh. This is the kinetic energy at h over 4 divided by the gravitational potential energy at height h. The gravitational potential energy at height h is mgh. So mgh with mgh, they cancel out. So I will have 3 over 4. 3 over 4. So the correct answer is A. A. 3 over 4. Okay, we'll continue, inshallah, the rest of the questions in the next video, inshallah.